Welcome to the Slop Farm. Enjoy the video.
You start by opening the part and working on a copy so the original stays intact. Once the copy is saved, switch to part design and confirm units. This prevents unintended scale shifts. Next, inspect datum planes and feature history so you know what to scale and what to leave. Make sure any assembly constraints or external references are noted. Otherwise, scaled geometry can break mates. Now, select the main body or the specific geometries you plan to scale down. You now apply the scale transformation. Choose Transform then Scale or use Insert Transformation Scale depending on your interface. Enter a uniform factor, for example 0. 75 to reduce size to 75%. This preserves proportions. Once entered, pick a reference point. Using the part origin or a datum gives predictable results. Preview the result and inspect feature links. Because scaling can alter constraint geometry, make sure sketches and dimensional parameters still behave as intended before accepting the operation. After scaling, rebuild the model and update any driven dimensions or formulas so they reflect the new size. Otherwise, downstream features may fail. Then run checks, mass properties, interference, and draft analyses to ensure functional fit. Once satisfied, save a versioned file name and record the exact scale factor you used for traceability. Troubleshooting tip: if constraints break, revert to the copy, suppress the scale, and reapply scaling only to solid bodies, or use
Thanks for watching. Consider subscribing if we helped you today.